4.1 vocabulary, which you can use on your quizzes on Friday probably. We did 4.2 notes, vocabulary, you can use on your quiz and whatnot. We did problems 1 and 2. So you guys okay with number 2? Did I go through it too fast at the end of the hour? You want me to kind of briefly go over number 2? An object, I'll go briefly over number 2. An object is dropped from the roof of a 120-foot building. We used to throw all kinds of stuff off of buildings. I haven't thrown a person off yet, but it's on my bucket list. All right, how long must it fall to hit the ground? So we're looking for that x-intercept of 120 foot. I use the example of a pumpkin or something. Start off of a 120-foot building, boom, splat on the ground. Looks really cool. And we're supposed to come up with the time of that x-intercept point, or actually t-intercept. And we have to use the equation -16 because we're dealing with feet. That's standard American, right? And we're looking for t, so this is actually s of t. T squared, we're trying to solve the initial velocity before we drop that pumpkin. The initial velocity, 0. Okay, it's not going anywhere initially. Okay, and then our initial height is the 120. And I told you guys, well, go ahead and graph this parabola here, because it's a quadratic function, right? Being a 2. And we found out where that x-intercept was. Okay, a couple of things happened. Let's review. When we put this quadratic function in our calculator, right? Let's see, we put in -16x squared plus 120. And when you went to go graph this, you get these 2 lines because our scale is 10. So we get this really blown up thing. We're trying to find this point, this x-intercept point, which looks between 2 and 3. But believe it or not, this is a parabola, but we just can't see it. So then a parabola. So then I said, well, let's go to our window here and let's think about this for a minute. My y-axis here, well, my height is 120 feet. So I told you, go into your window, make your y max, not just 4, but I think you guys probably have 10. Make it like 140, something bigger than 120, right? So I'm going to put 140 for my max. I think yesterday I used -5. Go ahead and put -20 in there if you want to see more of your parabola. And then our x max, what did I say, between 2 and 3? Maybe put 4 in there. Then graph it. And you should see more of your parabola. Make it easier to get this 0. How did we get the 0 for that? The x-intercept? Why, that's right, children. We went to our second trace, and we got our 0. Okay? Then we hit enter, and it asks us for left bound. I'm going to get closer to my x-intercept. It asked me for my left bound. I hit enter. Right bound, get to the right of that point. Oops, screwed it up. Do it over again. Left bound, enter. Then right bound, I got to get to the right of that intercept, or below on the other side of the line, axis. Hit enter, then hit enter again, and found to be that distance and the t-axis to be 2.74. Well, lo and behold, that is our time axis. So it took 2.7 seconds for this object to hit the ground. Easy peasy, right? It's going to be on your quiz on probably Friday. Most likely Friday. No, I'm debating whether to put it on YouTube or not. Sure. I'm sure you're going to get some extra study. All right, so let's do a couple more examples. As Bob Seeger would say, turn the page. All right, number 3. You are playing basketball in a European league, so we cannot use negative 16 feet per second anymore, can we? We can't use negative 16 feet. So now we have to use negative 9.8. And again, we're looking for how many seconds, so I'm going to do S of t, seconds of time, equals negative 9.8, and we're still looking for the time, so that's going to stay the same. Let's see. You release the ball at a height of 1.9 meters. What's that? Release the ball at a height of 1.9 meters. Which one of our variables is that? That is the initial height. Okay? That's our h of 0. Okay? With, wow, we don't even have to think about this one. Initial velocity. V sub 0 is 8.1 meters per second. Well, that comes next in our formula, right? So plus V sub 0, which is 8.1 times t, plus our h of 0, which is 1.9. Now, be careful with this, because I screwed this up in one of my other classes. It says how many seconds until it reaches the rim, which is 3.05 meters high. So I highly suggest making a picture. Okay, it's my height. My height, or y-axis, right? Here's my time, x or t-axis. Okay. So this guy, I'm assuming that the 1.9 meters is the guy's height. 6 feet. Okay, so there's my 1.9 meters. He throws this basketball up, hits the rim, boom, goes through, and falls down. Okay. So this rim has a height of how many meters? Has a height of how many meters? 3.05. So this is 3.05, which is, yes, you guessed it, it's the y coordinate of my vertex. And we have to find, because it says how many seconds till it reaches the rim, so we need to find this time here where it reaches the rim, which is going to be our t value of the vertex. So what's our plan of action here? Huh? What? What'd you say? Did you say something mathematical? No. I was excited there for a second. What's our plan of action? Well, we're going to put it on our calculator's, graph it, then find this point, this vertex, which happens to be a maximum point, right? And then it'll tell us what t is. Easy peasy. Yikes. 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 Okay, so I'm going to hit my zoom button, go back to my default, my zoom button, and hit standard, zoom standard, number 6, to get my graph back at its default setting. So hit your zoom key, Go to zoom standard, hit enter. And it defaults your graph back to your default graph settings. Okay? Wait for it. Pardon me? Why? What'd I do? Am I going too fast? Standard, number 6. Okay, let's put our new equation in. I have negative 9.8 x squared plus 8.1 x plus 1.9. I'm going to graph this. Graph. And this is kind of small for me to, I'm old and I can't see. I'm half blind. So I'm going to adjust my window again. I don't need all this negative y here, so I'm going to take off some. This negative 10 is my max. I'm going to put this at like negative 5. Could use more here, so I'm going to put my y max. We know it's not past 3.05. I'm going to put 4. And my x max or x min or y min, sorry, let's do y min. I don't need all that negative stuff, so I'm going to go half that, negative 5. Time, I'm going to put 5. Certainly don't need so much negative x, maybe negative 5. Let's see what happens with this one. Yeah, pretty good. Okay. Again, I'm looking for the x coordinate of that vertex, right? It's going to tell me the time. So, is this a maximum point or a minimum point? Is this a maximum point or a minimum point? Max. So I'm going to go to second trace or calculate. Look for my maximum. Hit enter. My whole left thing be the left of the vertex. Hit enter. Right to the vertex. Hit enter. And hit enter again. And it gives me an x value of 0.41326. Well, about 0.41. Okay. So that's my time. Half a second for it to reach the rim. Which is, I don't know, a meter, right? From 1.9 to 3. About a half a second. Makes sense to me. Just checking. So 0.41 seconds. Oh, down here. 0.4 seconds. Now, when I'm looking at this, I'm thinking to myself, when I first did this, that I did something wrong. Because it says my height here of the rim is 3.57. And it says here that my height is 3.05. So I don't know what's going on. And I tried retyping it and doing it different ways. The only thing I haven't tried is actually doing this manually. And not sure if I want to do that. But we could, couldn't we? Yes, we could. Very easily. It's on your notes from yesterday, right? The x coordinate of the vertex is negative b over 2a, isn't it? Okay. What's my b? 8.1 over 2 times my a, negative 9.8. Okay, well, negative 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 is going to make it positive. So I have 8.1 over 2, oops, 2 times 9.8. I get 19.6. I'm going to take 8.1 and divide it by 19.6. And I get 0.413265. Guess what? It's the same number. So I'm 100% sure at this point that it's 0.41 seconds. Okay. By the way, there's all kinds of ways we can do this problem. Want all of them? Nah, that's way too much work for me. I want to sit back and just collect the dough from teaching. Okay, I never did number 4. Let's check it out here. Your calculator can also help you solve some non-real word problems as well. The area of a rectangle shown is 105 meters squared. Find the value of x and the dimensions of the rectangle. I'm not sure what this means. Well, we know what the area of a rectangle is, right? Length times width. Okay? We know the area to be 105 meters squared. That equals our length, 2x plus 1 times our width, which is x. Now, I'm assuming that they want us to solve this like a quadratic model. So we'll make it a quadratic function, which it is already. Just going to make it simplified. So 105, I'm going to distribute the x. X times 2x is 2x squared. X times positive 1 is plus x. And then I'm going to subtract 105 from both sides. And I get 0 equals 2x squared plus x minus 105. And guess what? I can plug that into my calculator, right? And draw a parabola. I can put this quadratic function in my calculator and make a parabola. See how fun this is? All these different ways you can solve problems now. Okay, so I have 2x squared plus x minus 105. Hit enter. Uh-oh. 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 No, it's out of my window. That's the thing. I don't feel like messing with my window. Why don't we just factor? Do you factor this? Or do you want to play with the window? I play with it. Give me a choice. Boy, oh boy, I'm going to do it the hardest way possible. Oh, hey, look at that. Okay, so my x is a distance or a dimension, right? I'm not going to choose negative. My x has to be positive, so I'm going to grab this intercept here. That's going to tell me what my x is, because my y has got to be 0. Okay, so I'm going to go to second, trace, calculate my 0. Let's see, left bound. It's got to be out here somewhere between 1, 2, 3, 4, 5, 6. I'm going to bring my x to 6 so I can see my cursor. 5, 6. There it is. I'm going to hit enter. Go to the right bound, which means going over the line. Hit enter and enter again. And I get 7. Easy peasy, right? What are my dimensions? Well, width equals 7. Length equals 2 times 7 plus 1, which is 8. Wasn't that fun? Any questions? Okay. Your homework's bookwork. The length. Because our length is 2x plus 1. And our width is x. Any other questions?